Okay, so thank you for coming. My name is Juan, and I'm from 武蔵大学国際教養学部 Economics and Management program. I'm teaching economics courses, and for the second year and third year and fourth year students. Okay, so and we are going to talk about economic application in solving a business problem today, okay? And so the language we're using today is going to be mainly English. Some of the Japanese words will be marked in the slides to help you understand. Okay. All right, so let's get started. So in today's class, we will introduce an economic way of thinking to solve a business problem. And we will introduce this business problem and walk you through the ways we solve this problem. And in the second part, we will also illustrate how to use mathematical concepts to help in finding the optimal solution of the same business problem. Okay, so those are the two parts for today's class, okay? And the reason I'm talking about mathematics is because this lecture is part of my Mathematics and Statistic 1 course, which is the second year 2年生の class の一つ Mathematics 1 and Statistic 1. And so we will be using mathematical concepts to solve economic and business problems, right? So we are not learning math for the purpose of solving mathematical questions, but we will show you how the mathematical concepts can be used in economic settings, okay? All right, so let's start. Let's start with a scenario. Suppose you are going to run a bagel shop in Musashi University. There is no such bagel shop right now, right? So bagel shop, do you know bagel? You know it, right? So bagel in Nihongo. And then we're gonna sell this New York style bagel. Do you know what is a New York style bagel? If you've ever been to New York, and you probably should try one of the bagel shops there. And I used to live in New Jersey, which is just very close to New York City. And one of the favorite food on Sunday morning for Americans are what's called bagel and lox. And lox is referring to, I guess not many of you heard about that word before, L-O-X. So bagel and lox is referring to the type of bagel that has lox in it. So lox is referring to a salted or smoked salmon. So salmon, sake in Japanese, okay? So you put that smoked salmon in the bagel together with cream cheese. And it tastes really good. And so suppose it's hard to find that kind of food in Japan. So suppose you are going to run a bagel shop in Musashi University. And so there's a picture of that bagel. And then let's suppose you are going to sell each bagel for 600 yen per bagel. Okay, and that is what we call the market price. So market price means that it is the price, that is the average price in the market for that kind of bagel, okay? So a similar shop sells a similar bagel for roughly 600 yen. So that's the market price for bagel. And then the question that we want to answer today is an economic question related to how many bagels would you make per day? So in terms of production level, how many bagels is optimal? How many bagels is the best, right, to produce per day? So in order to answer this question, what kind of information do you need? So in order to answer this, how many bagels would you make per day? In order to answer this question, what kind of information is needed? So in order to answer this question, what kind of information do we need? So we know the bagel price is 600 yen, well, assuming that's not changeable. So what other information do you need? So basically, how many people are willing to pay for the bagel, right? How many similar bagel shops are around that area, right? And those are all related to what we call demand for the bagel, right? So the keyword, so demand. Okay. So that's of course important. On the other side, there is also the cost that's important for the business, right? It doesn't make sense to sell a bagel if your cost is higher than the money you can collect, right? So you need to know both sides of the information, right? How much money can you sell? Well, in English we call it revenue. In Japanese, uriage, right? So your revenue needs to cover the cost in intuition, right? So in tuition, we want the revenue to cover the cost. So I'm giving you a little bit of cost information in that table. And so in this table, you can see, for example, the total cost of producing 10 bagels, right? The total cost of producing 10 bagels is going to be 7,500, right? So this red dot. And the total cost of producing 20 bagels is going to be 11,000 yen. So this is all in terms of yen, Japanese yen. Okay. And the total cost of producing 0 bagels is still at 5,000. Now, do you make sense of that number? So why would the total cost be 5,000 even if you don't produce any bagel? So before production, what kind of cost would you incur? Like before you opening up the shop, what kind of cost do you incur? One example, rent. You have to pay rent, right? Rent は日本語は家賃. Is that right? Okay, so you need to pay rent, right? And you need to buy machines. For example, to bake the bagel, you need an oven, right? So you need to buy tables and chairs, right? So those kind of costs are basically what we call fixed cost. So that's the cost when you don't produce, that's the cost you need to pay before production happens, right? Okay, so given this cost structure, let's figure out the answer for this question. How many bagels would you make per day? And here, one of the important economic assumptions we're making is that we're assuming the firm, or in this case, the bagel shop, is maximizing its profit. Rijin Saidaika is the Japanese word for it. And so this may not necessarily be the case because sometimes firms, motivation is to sell as many bagels as possible. It's not necessarily profit. However, we're assuming that profit is the goal. Okay, so suppose we're assuming profit is the goal. So we are going to calculate profit using this table. And so here, in order to calculate profit, we need information on the price of the bagel as well as the output. Okay, so the price is kagaku, and the output per day is suryo. And then we are going to use this equation for profit to calculate the actual numbers, right? So this equation, profit is the difference between revenue and cost. Okay, so we're going to use this equation to calculate cost. And so first of all, we need numbers for revenue, right? So this is shown in the third column of the numbers. Okay, so revenue is defined as the price per bagel times how many bagels you're selling, right? So the price per bagel multiplied by how many bagels you're selling, and that's the total revenue. So for example, if you're selling 10 bagels per day, then the price is 600, right? And multiplied by the quantity here, Q, is going to be 10, right? So this gives us 6,000, right? So this is if you're selling 10 bagels per day, then the revenue you collect, 우리하게, is going to be 6,000 yen, right? And the corresponding total cost is going to be 7,500. Okay. So the corresponding profit based on these two numbers is going to be 6,000 minus 7,500. So you would get negative 1,500. Right? So that's 6,000 minus 7,500. Okay, so that's how we obtain profit, and you can do this for each level of bagels, each level of production. And so based on this calculation, I actually calculate the entire table for you. And so as you can see, for example, if you're selling 20 bagels per day, then the total cost is 11,000, total revenue is 12,000, and you would have a profit of 1,000, all right? So for some of the levels, the profit is negative, for others, it's positive. So based on this table, let's answer this question then. How many bagels should we produce per day? How many bagels should we produce per day? 40. Everybody agree? How many bagels should we produce per day? We are trying to maximize the profit, right? And the profit here at 40 bagel is going to be 3,000. So as you can see, at 40 bagel, the profit is the highest number at 3,000. Okay? So this is the intuition of profit maximization. Essentially, we need information on the revenue and information on the cost. And then we can construct profit based on these two information. And then we can get the answer, which is the number of bagel we should produce is 40, because 40 maximizes our profit. Okay? So some people say, why are we not producing more than 40? Why are we not producing at 50? At 50, as you can see, of course, your total revenue is higher, but your total cost is also higher, right? So your profit is actually lower. So it doesn't make sense to produce 50 because your profit is smaller than the number bigger at 40. Okay, so this is just the introduction to the intuition behind what we're going to do. And then right now, I'm going to introduce you another way of solving the same problem is that we are going to use mathematics. And suppose we can define the cost function and revenue function using equations. So the total cost function is displayed here as 5,000 plus 200Q plus 5Q squared. Okay, so your total cost is a function of your output Q, and that's, you can actually double check that function is consistent with the total cost column, right? For example, if you plug in Q is 0, then the total cost is 5,000, and so on. Okay, so suppose we can use this function to capture the total cost, and also use another function to capture total revenue. So in this case, total revenue, remember, is P times Q. So in this case, our P is 600, and Q is something we want to find, so we leave as it is. Okay? So suppose we want to use these two functions to find the optimal level of production. So what do we do here is that we are going to write out the profit function, okay, which we use pi. We typically use pi for profit. Okay, so profit is a function of output. And so we use total revenue minus total cost. And so we're going to do subtraction. So we're going to use total revenue, which is 600Q. And then we're going to minus that total cost function, which is the 5,000 plus 200Q plus 5Q squared. Okay? So this is the total revenue, and this side is the total cost. Okay? So we're going to construct the profit function as a function of the output. So in this case, we would have 400Q, right? And then minus 5Q squared and minus 5,000. Okay? So this is what we call the quadratic form, means that there is a square in front of Q. Okay? So Q is the variable of interest. So we want to find what level of Q would maximize. So what level of Q would maximize the profit function. Okay, so this is a typical mathematical question. So how do we find the level of Q that would achieve the highest level of profit? So that's the mathematical way of thinking about this same question. Okay, so then how do we do this? There are many ways to do this. So we are going to introduce the way that we do this is to use calculus. Okay, so calculus in Japanese, bisekibun, right? So basically in my course, we will study bibun and sekibun separately. So there is a word called differentiation, and a more common word you'll see it again and again in this course is called derivative. Okay, so derivative of a function, right? So that's bibun English. Okay, so in plain terms, it's the rate of change with respect to two variables, y and x. Okay, and also it's related to another term in Japanese. I guess you're not so familiar with these mathematical terms in English. So another term is slope. And slope is called katamuki. So, right? So in Japanese, katamuki. So basically, it's a slope of a curve at a given point. And this is a very, very important mathematical concept because it is often used to find, the maximum or the minimum of a function. All right. So I will introduce a little bit about the basics of derivative or differentiation, and then we're going to solve this problem together. Okay. All right. So we're going to exit this, and then we're going to change to this slides because it's easier to actually write on this slides. Okay, so I'm going to sit down because then it's easier to write. Okay, so the basics of derivative, right? So suppose, right, so you have a curve. Okay. So this is y and this is x, right? So suppose you have a curve like this, right? And so what is the slope concept, which is basically you're giving 2 points. So this is A, this is B, right? So the slope concept is basically the change of, here is the change of x, here's the change of y, right? So the rate of change, right? So the rate of change between A and B, is basically the change of y over the change of x, right? So that's kind of the basic concept of rate of change. Now suppose you're trying to figure out the rate of change at one point, okay? Suppose at this point of x1. So instead of looking at an interval here, we're trying to figure out how fast is y changing at one point, right? So at exactly x1, right? So then that is the concept of derivative. And we use dy over dx for that, okay? dy over dx. So at is exactly x1, right? How fast is y changing at x1? So this d stands for a very small change, okay? A very small change in x. And another notation is that if you define y as a function of x, then we use f prime x to define derivative, okay, dy over dx, okay? So these are the basics of derivative. So basically it's measuring the slope of this curve. And as you can see here, the slope is all positive, right? So the slope is positive because as x increases, y also increases, okay? So, okay. So let's then look at a curve. So suppose we have a curve like this. Okay, so let's look at another curve. So suppose we have a curve like this, all right? And this is y and this is x, okay? Now in terms of slope, what do we see here? So this part is positive, right? So because we're climbing up a hill, as x increases, y increases. Now what about here, the slope? So katamuki. So here is going to be what we call negative, right? Because as x increases, y actually falls. Okay. Now what about this point? At this point. So at this point, what's the slope? So if this part, So if this part part, the dy, so if this part, the dy over dx is positive because we're going up the hill, right? And this part, dy over dx, is negative. And what about this point? What's the value at the top of the hill? Well, that's the maximum value we want to find, right? So what's the value at the top of the hill? What's the slope? What's the slope? Any idea? Any volunteer? Is what? At the top of the hill, the slope is what? So what's in between a positive and negative? Positive number, negative number, what's in between? Zero, exactly. Very good. Thank you very much. Yeah. So that part, the derivative is 0. Very good. So that's the optimization condition that we're looking for. We are looking for that the derivative is 0 because at the top of the hill, you're not moving, right? So you climb a mountain at the top, there's a very tiny flat part, and that's when the slope is 0. And so does this point, right? So at the lowest point, it's also 0, correct? Okay, so then basically all we want here is to find, so if we are looking, if this is the pi function, right? So if we're looking at the profit function, basically the outcome is the profit and the x variable is the q, right? We're looking at, so the same condition here is that we are looking at the derivative of this function is 0, right? So derivative with respect to q is essentially 0, right? So in order to find the maximum of this function, we need to calculate the derivative and set the derivative to be 0, right? Well, of course, some people say, oh, then there are 2 points, right? This is 0, this is 0. How do I know I'm at the top of the mountain or the bottom of the mountain? How do I know? Well, that requires an additional mathematical condition, so you don't have to worry about now. So let's figure out the derivative of this pi function together, okay? So that requires a little bit of basic knowledge in derivative. Okay, so the basic knowledge is that, okay, so if you have a function of, let's say, I'll change the color. Let's say if you have a function of, so if fx is, let's say fx is kx, okay, if you have this function, or k is basically a number, some kind of number, what we call constant. Constant is a number. So for example, fx could be equal to, 3x, okay? Then f prime x is going to be equal to 3, okay? So that's one of the rule. The other rule is if fx is kx squared, then f prime x is going to be 2kx, okay? Okay, so then the last rule is that if fx is just a constant k, then f prime x is going to be 0, okay? So these 3 rules, 1, 2, and 3, are very useful here to solve this question, all right? So let's do it together. So you don't worry if you don't remember, if you don't know these rules. The first year class in Musashi, in our program, you would learn these basic mathematical concepts, and you do a lot of exercise together in class. So don't worry if you're like, I'm totally lost. Don't worry about it. Okay, so 心配しないでください. So because we're going to do a lot of exercise together, and so that helps you to figure out this question. Okay, so let's use this rule to get the derivative of the profit function. Okay, so I want to get pi prime q. I want to get the slope of this curve as a function of q. So what do we get? So using these rules, okay, so using rule number one, so this is a k, this is like a k times q, right? So then the derivative of this function, so we look at them separately, okay? So look at this function, this function, this function separately. Okay, so for the first term, the derivative is going to be 400, okay? Because this is kq, and essentially the derivative is just a k, okay? So that's rule number one. And using rule number two, okay, so using rule number two, this is kq squared. So what do we get here? What do we get? The derivative of this term is going to be, any idea? So minus, this 2 is going to come in the front, right? And times 5, and then Q, okay? So basically the power here, the 2 is going to come to the front, multiplied by the KQ, okay? So it's 2KQ, so essentially it's 10Q. And then the cycle, this is rule number 3, if you have a constant, there is no Q in there, then essentially it's a 0, okay? So it doesn't change. Okay, so then the derivative of this function becomes 400 minus 10Q. And then at the top of the hill, remember, we need to set this function to be equal to 0, right? And then we can solve for Q. Then Q is going to be equal to, so Q is going to be equal to 40, right? 40, all right? So that's how we can get the same answer as using the table, right? So as we first used the table and did the intuition, calculate the profit, I'm finding that at the, remember this table? So at 40 level, 40 numbers a bagel, the profit is the highest at 3,000. And by using mathematics, by using the concept of derivative, we essentially can get the same answer as the table way, okay? So that's basically the main story of today's class, is how to use a mathematical concept to find the optimal level of a function, okay? Okay, so at the end, we're going to make sense of this profit function just a little bit. So this is probably your high school material. So if you are going to draw out this profit function, how does it look like? So if this is the profit and this is the output, right? So if you're going to draw out this function, this profit function, how does it look like? If you have a piece of paper, so how do you draw out this function? How does it look like? This essentially have a squared, right? What do you call nijishiki, right? So how do you draw this function? This function will be basically, how does it look like? It will be basically like this, right? Facing down. The reason is because this term is negative, right? So it's going to be face down like this. And we know at 40, so if this is 10, 20, 30, and 40, 50, 60, and 70. So we know at 40, this function is maximized at 3,000, right? So we know at 40 bagel, right, the profit is maximized at 3,000 yen. And so this is the highest point of the hill. And then it's going to come down this way and come down this way, okay? So this is the profit function, essentially, all right? So the highest point is where we maximized. And then it's going to come down and crossing that horizontal line at two levels, 2 points. One is this point, and one is this point, okay? So this red one and this red one, okay? So that's kind of how this function is going to look like. So the intuition is that the profit function is going to climb up until this part, and then it's going to fall down, all right? It's going to fall down. So we're trying to find this point where profit is maximized. And so another important piece of information is actually this point. In business setting, this point has a name. Do you know that? What's important about this point? What's the name for this point? This point is called break-even point. This point is called break-even point. So this is when the profit is just about to become positive, right? So this is when the profit here is negative, right? So negative. And then it crosses this point is 0, and then here it becomes positive, right? So the profit goes from negative to positive, and that's called the break-even point, okay? And for business, it's important because this is the level of output that makes their revenue and cost just equal, and their profit is essentially 0 at this point, okay? Okay, all right. To summarize a little bit of what we have learned so far, maybe we use this side. And so what we did so far in this class is that we assume that firms are maximizing their profits, and we define the profit function as the difference between revenue and cost, right? And then we use the mathematical way to generate the same answers by basically defining the revenue function and the cost function. And so the revenue function in business terms is essentially related to how consumers are willing to pay for your product. So essentially it's related to consumers' demand for the product. So that's how usually revenue is generated. Whereas cost is related to like your fixed cost, your variable cost, all kinds of costs incurred in production, okay? And so combining these two factors, we can find the profit maximizing output by using the mathematical concept of derivative, by setting the derivative to be equal to 0, okay? Okay, so finally, in the last slide, I want everybody to think about this framework a little bit, because this is related to the current situation that actually the bagel price in the United States has been rising sharply in the recent month because several things are changing. So number one, the price for flour goes up. So which component, so think about this in an economic way, so which component will change if the price of komugiko goes up? And we know making bagel requires using flour, right? So if the price of komugiko goes up, will that change TR or TC? TC, thank you very much. Because komugiko is used as an input, right? So it's used to produce bagel, and so TC will change. And so if TC change, then the profit function would necessarily change. Okay, let's look at the second one. If more people want to buy New York style bagel, so what factor would change? TR or TC? If more people are willing to buy, wanted to try, TR or TC? TR, right? TR because this is basically the demand side, which shows how many people are willing to buy the bagel at a given price. Okay, last one. What if the rent, so you have to open up a shop and the rent price increases? So which factor would change, TR or TC? TC, right? So basically, so rent is part of the fixed cost, and that would necessarily increase the total cost as well. So basically, the bottom line is that so in reality, no firms are doing this economic calculation every day, right? So what we're doing here, nobody is doing in our business every day. So that's impossible. But then why are we learning about this? Because this is a framework that helps us to think if something changes in the market, how do we predict what's going to happen next, right? How do we think about what's going to happen to my business, what's going to happen to the competitor's business, what's going to happen to the industry, right? So this is a framework that helps us to analyze, or bunseki, right? Bunseki, the behavior of the firms, and to better understand how firms changes their strategy given the changing economic conditions. Right? Okay, so that's kind of the bottom of my class, and hopefully it's not too confusing. Hopefully I'm not discouraging anybody by using mathematics, but it is, and so the reason I want to show this is because mathematics is really, really important in business and economic studies. So yes, and you would get